Hi, welcome to this weekly ZP Developers webinar. So we like to do this webinar once a week, and it's really just answering technical questions that have come in during the week. Sometimes it may be technical and a bit of also sort of, I don't want to say business advice, but also sort of commercial strategy. So I've got the date 5th of January 2025. We sometimes on the weekend have to mix it up. You know, there's lots of commitments to be made on the weekend. So in fact, I'm doing this on the 4th of January. But that said, this is our weekly webinar. Just to say that any kind of text that we link to today, you can get a 10% discount on the web store for January just by using this link and this discount code. With that said, let me just jump into the questions first of all. So I'm going to sort of do a bit of a deeper dive, not the deepest dive I've ever done, into point of care diagnostics. Things like, you know, gold versus carbon when it comes to point of care diagnostics, and also just diagnostics more in general, and also the cost of getting to market. Now, I'll also discuss collaborations with ZP as well, but I must be very careful that ZP, we have invested in clients in the past, but these have always been clients that are kind of very big clients. So we've always, not always, but we have invested in clients. I can think of our two most significant clients have been invested, but ZP is not a VC firm, and ZP is also not an academic institution. So those often in all interactions with us really have to be funded by the client themselves. They have to have the kind of funding to do this. I'll also just touch upon oxygen sensing as well, but this will be quite fast when I actually touch upon oxygen sensing. The reason I do this is because if you're kind of not interested in question 1, jump to question 2, and if question 2 is your focus, again, just jump to question 2. All right, I just want to do a quick comment as well that we are having an in-person workshop in January 2025. I think it's about the 22nd of January. It's a 2-day workshop. I'll put a link to that, and so if people are kind of have further questions or want to sort of, you know, come to us, talk about wearables, do there's both presentations, but there's also go in the lab and do practical work as well. So that will be happening on the 22nd of January in Norway, 2025. I just put here a quick comment for myself to do a demo. So I've got some hardware in front of me. So let me just go to external. So first of all, I've got this app installed on my phone. You can get this app off the Google Play Store or the Apple App Store. I've actually got it in impedance spectroscopy mode at the moment. So what this means is it actually says device connected. So it's in Bluetooth connection with this particular device. But the first thing I want to do is actually do cyclic voltammetry on it. Now, the reason I'm bringing all this up is because I'm going to talk in a minute about development of medical diagnostics. And I've talked about making, let's say, immunotype sensors just sort of recent. And I sort of said there, well, you know, cyclic voltammetry is a good way of characterizing the electrodes doing the fabrication. I just want to show you that this is a very unusual type of let's say potentiostat, because it can be both what we call a MVP. Now I'm going to use a slightly different definition of MVP here, minimally viable prototype. I've got to be careful with it if I use MVP also, because it can mean minimally viable product. But in the medical diagnostics industry, it's harder to use that concept of minimally viable product, because medical grade product should really have regulatory clearance, and it's hard to have a prototype with regulatory clearance. Anyway, that said, you saw me just put it into cyclic voltammetry mode. I'm just going to put a sample onto that just to kind of show that this instrument, I'm going to do 3 demos this morning, or at least I'll do 3 runs on it. So the first one I'll do is just cyclic voltammetry. A good method when you're building immunosensors to kind of check that you're actually modifying the electrode in some sort of meaningful way. You'll notice often when ZP's doing assays that we try to do everything quite straightforward. So I've got the start potential, the end potential, the scan rate, the number of scans, the current range, which I could tick up a little bit, but I'm not gonna bother. This will only take about 18 seconds. If you're developing medical diagnostics, you'll see it in some of my notes in a minute that people want them to be rapid, so don't develop assays that are intrinsically slow. It's definitely something that we try to avoid at Zimmer and Pico. This is a very unusual instrument because what I'll show you now is that it can do things like cyclic voltammetry. It can also do impedance spectroscopy. and I'll also do, let's say, a real world application as well. But the first thing I want to do is I'm just going to navigate on my my computer. So let me just share my screen too here. So what it did say on the app is, and I'll just bring the app, it's a very small to see, but it says upload complete. So it grabbed that cycle voltammetry very quickly, and it actually uploaded it to the cloud. And this is a very powerful kind of feature of this, that there we go. So I can see the data up here now. Like I said, I just did a quick experiment this morning, and I can sort of quickly see that I've gathered that kind of CV. I can do all sorts of manipulation on this CV because we've got a whole sort of data pipe actually built into this, where I can do all sorts of processing of that, and actually turn that into a meaningful concentration much quicker than going from signal to actual results. You'll see me do a demo of that in a minute, but just to say that this instrument, in the first instance, I was able to do cycle voltammetry. Now I'll just go into EIS. So I'm just going to click done on this. I'll open up my camera again. Linear sweep, which is there. EIS is there. So now I've got EIS, electrochemical impedance spectroscopy. I'll just change the name slightly so I can find this later on. And S. Done. Continue. I like to do things fairly fast. So fairly fast sometimes means not actually using the full, now purists, in fact, I'll do it really fast just to get a quick, so the reason I say I could do it fairly fast is because actually I didn't set the frequency range from like 1 to 1 hertz. I've actually put it at 1,000 hertz. I know purists will say, oh my goodness, well, the point is, if you want to do an assay, especially point of care assays, people don't want to be hanging around, especially nurses and doctors. These are busy people. So I'm using some of the faster scan rates. I'm just going to apply a potential of about 100 millivolts, and I'll just put an AC amplitude on that of 10 millivolts. I'll go back. I just want to, I did call it that. That's okay. I'll start the measurement. And so that will actually then run an EIS experiment as well. Now, the reason I say all that is because if you're doing things like immunoassays, you'll need sort of several functionalities. You may need cycle voltammetry for actually doing the functionalization or the building of your sensor, so you can show that you were successful in sort of layering up, and there we are, upload complete, to show that you were successful in layering all the kind of layers upon one another. You may then need EIS or maybe square wave voltammetry. I've got square wave voltammetry here as well. These are both good techniques when it comes to there we are, square wave voltammetry. EIS and square wave voltammetry are good for actually reading the final assay itself. But now I want to show the real power of this instrument, that this is a scientific tool, that I know it's strictly speaking a potentiostat, but I think sometimes electrochemists become too obsessed with the electrochemistry, and they've got to keep their eye on actually what they're trying to achieve, which is actually to make impactful products. So what I want to do is I just want to put a different sensor on here. So I'll just take that one out. I'll put this one in here, because now I'm showing you that the same instrument, as long as people are working with ZP, can actually become a, dare I say it, a real I do dare say a real product. So let me just put a clean pipette on here. Let me just get the sample itself. Let me pipette on. And this is a good example of how we like to get our assays to be quick. This is the kind of a real demonstration of all the power of electrochemistry. Again now, so what we're able to do is people are able to afford the interaction with ZP. Now what I've done is I've actually scanned it, and it's become application specific. So in fact, I'll just give that a name. Tab 55, that'll do. Continue, start. And now it's actually running an analysis now. But this is different this time, because in fact this time we've set up the cloud system so that it will actually return a result to the phone, which it's actually done. So this is a really important one, see, because in a hospital setting, people don't want to just see upload complete. They actually want a concentration. So here, for example, I think it says 1200 micromolar. So you can see that the same instrument, I was able to, well, at least I did a cycle voltammetry. I was able to go into EIS mode, which I ran. I was also able to go into square wave voltammetry. And I'm also able to then show you that actually, you know, rather than sort of leaving people hanging with just, you know, voltammetry, we can actually, or even impedance spectroscopy, we can actually turn those kind of results into a, turn those kind of science into an actual number. Now, what I want to do is just go to my screen 2 here, which is coming. I'll just go to here. The power of it is that if you're working with doctors or nurses and in a hospital setting, you then, especially in your kind of, you know, early trials, you can actually go up there and just ensure that all the data is being gathered correctly, that the signals are strong, etc. So I do that because this is a very unusual type of instrument. It can do EIS, it can do square wave voltammetry, it can do impedance spectroscopy, it can do amperometry, it can do open circuit potentiometry, it can do linear sweep voltammetry, and it can gather that data, send it to the cloud, but it can also process that data and actually return concentrations back to the phone. So I did that because then everything else I'm going to do now will be in the kind of context of that. So question number 1, for impedance, somebody's asking, you know, gold versus carbon. Gold has a reputation for having a lower resistance in the conductive tracks than carbon. It's an opinion, but in the end, at ZP, if somebody's properly funded and they can afford our work, we probably end up trying to do gold and carbon. But on balance, I've said it before and I'll say it again. In fact, I've got a slide on it, that people, when you've got a technical background, you tend to focus on the technical aspect, which is important, I get it. But actually, you've got to think to yourself, am I ever going to make this in a low-cost sensor? And gold, I know I've said it, and I've said it in a few weeks, doesn't translate well for low cost. So sure, gold is probably more, well, gold is more conductive than carbon. But will it lead to a low-cost sensor? And I would super argue that carbon will and gold will not. That's my opinion, but you have to do the business case. So that particular device, for example, that I was just testing, we sell that on our web store for €1,600. I'll be putting a link for that particular device in a minute. Just out of interest, if somebody comes to us and says, look, I haven't got much budget, but you know, I'd like to kind of, when they say collaborate, I mean, the easiest way to collaborate with ZP is, you know, is to have the correct kind of budgets. But if you don't, then our technology platform, if you watch, our technology platform has been 10 years in development. From day one, the entire idea of ZP was how to reduce barriers to productization. So in fact, you know, the whole company, and you know, that's 10 years, you could easily, you know, think about how much investment we've made into this to actually get to this point where actually people can fairly quickly get to MVPs. So when I'm quoting you, I'll often be kind of quoting you this technology stack because I genuinely believe it's the fastest way to market, or at least to MVP. And when I'm quoting, I'll probably generally give people a pack of 100 screen printed electrodes. The potentiostat, as I say, is about €1,600. I'll put a link to it. And if people want to collaborate with us, they'll probably need fairly substantial budgets, but you can collaborate effectively with us through actually buying into the technology stack, which is getting screen printed electrodes from ZP. I have done videos about the reproducibility of our screen printed electrodes. I do give free advice on our web store, sorry, on our YouTube channel. So, you know, the advice earlier on, you know, about gold versus carbon is, you know, from a technical perspective, gold is more conductive than carbon. Is that what's holding somebody back from being on the market with their product? And I would absolutely suggest not. And gold will always be quite hard to translate into a low-cost solution. Working with ZP, the best way of working with ZP is to have substantial budgets so that you can essentially afford ZP to go in the lab and do some work for you, or to be a contract developer, contract manufacturer. But you need the budgets. Now, if you don't have the budgets, we sincerely have built this technology stack, which I've just done a demonstration of, over 10 years, just for one thing. Really to kind of, actually, there was a scenario I had in my head that somebody wanted to go out there and raise money, and the investors say, oh, well, seeing is believing. Show me some technology, and I'll invest in you. So in fact, this entire technology stack has been built with the idea that an investor has kind of challenged you to do a demonstration. And so, you kind of turn up with your hardware, you've got your app, you've got some sensors, and you do a demonstration. Now, you can't be guaranteeing them precision and accuracy, but it demonstrates that you have some hardware. And in fact, so the technology stack is entirely built for that scenario. So if somebody who has little funding, but they want to get funding, then we think this technology stack, if they turn up, show the investor where they're at, then they're in a sort of, they're in a more investable position, and then they can come back and either build their own team or work with Zimmer and Peacock. It's probably worth saying that ZP does do development of immunoassays. This is some work we did with a client years ago, using EIS, electrochemical impedance spectroscopy, and all this was gathered on our own technology stack. And I'll put a link to, so you can find this kind of potential stack, and you can find the screen printed electrodes that I'm recommended here. Also, we do have gold electrodes. Now, I'm always a pragmatist myself. So if there's a suspicion that, in the end, my go-to-market strategy may be actually to use carbon. But if I was struggling in my prototyping moments to kind of get to meet some milestones, I would possibly try carbon and gold, because I'm a pragmatist. So I'm going to try two things. Now, the reason I can do this sometimes is if the funding's in place, I can essentially have two, trained scientists both working in parallel. The problem with trying to do two things in parallel, if you're just one person, is you are definitely halving your effort. Of course, with a group like ZP, we can actually do two things in parallel because we have essentially multiple scientists and a well-equipped lab able to do this kind of work in parallel. But that's only really an option that can work with ZP if you're well-funded. Because essentially people have salaries and people need to be paid. But just to say that I'm not absolutely against gold. I do have a link here to some really good gold electrodes that we definitely use in binding assays with clients. And if the client is well-funded, we'll probably try carbon and gold. But if I don't think you're well-funded, then my advice is going to be go for carbon. But in the end, you do have to make that decision. Side comment. This is just a kind of comment. When people are very educated, either as an engineer or as a scientist, we tend to focus on, questions like gold versus carbon, let's say. But actually, this is a real detail. This is kind of, I can almost honestly say this is almost like, it's less than 5% of the real problem. Whether you do gold versus carbon, that's not really the problem. 95% of the problem is, are you funded? So be very careful about being myopic. When you're educated, and I've, got a PhD in electrochemistry. I'm sure many of you've got, lots of experience or, and PhDs or masters, etc. in these kind of subjects. Be very careful because you will focus in on the science and engineering because that's really what you're understanding and that's what your passion is. But understand that's only a small fraction of actually the real problem here is the elephant in the corner, if I can call it, is are you funded substantially? That's where you really need to be putting your energy, not in is it gold versus carbon. You need to get a okay, let's say, working prototype, get some investors. And if you can't get investors, you have to hear what they're saying, which is, whatever you're proposing at that time is not investable. So just out of interest, I did the demo earlier on because I wanted to show you that the particular instrument that I'm linked to underneath this video can do cyclovoltammetry, it can do EIS, and it's basically solved. As I say, ZP has been working on this for a good 10 years now. In fact, we've just entered our 11th year. And we were really trying to solve this problem, which is this kind of valley of death between academia and commercialization. And this kind of valley of death, I think it partly exists because people were using instruments in their research that were in no way reflective of what an actual product would look like. So you're trying to want to get a technology or an idea across this kind of chasm. But that chasm in part existed because people were actually using hardware that was very lab-based. But of course, when I'm showing this SenseltAll platform, I'm actually showing you something that's both a research tool and an MVP tool. So this kind of chasm between what we do in the lab and what we can do with real, let's say, users like doctors and nurses just really closed up. So there's a philosophy at ZP which I generally don't think necessarily exists in other companies. Other companies are trying to provide you with screen printed electrodes, gold electrodes that are sputtered. They're trying to provide you with potentiostats, but ZP is actually trying to provide with a technology stack that can genuinely take people to market. But in order to actually get into this, you have to genuinely essentially purchase this. Now, this is a classic. See, what I'm going to talk about here is spend, effort, and time. Companies spend a lot of time coming up the technology readiness level where they come from basic principle to system deployed, or in our field of medical diagnostics, that might be system, regulatory approval, etc. And now, realistically, people will say, oh, that'll take me 5 years. Genuinely, they actually take much more than, it's more like 10 to 15 years, and only 10% of people are actually successful. So there's a 90% failure rate. This is something that I perceived before we started Zimmer and Peacock. It's something I've definitely experienced a lot of. So the whole SenseltAll platform is actually trying to get this 2-year manifesto together, which means, look, people see these things as barriers. I've got to do my basic principles, I've got to do my technology concept, I've got to do my proof of concept, I've got to validate it in the lab, I've got to validate it in a relevant environment, I've got to do a demonstrator, I've got to do system prototype, I've got to do system complete and qualify, I've got to deploy the system. And we say this is all taking too long and taking too much money. And so with the SenseltAll platform, we're generally trying to eliminate some of the barriers. It still leaves a lot of the science to be done. You've got to come up with this assay, etc. But what we're trying to do is how can we get, so in fact, we've got more than 2 clients to market in less than 2 years, but they were well funded. When I say market, I should say CE marked. But that means you have to eliminate all of these barriers. Just out of interest, if there's a link here I'll put, but historically, I think before there was a Zimmer and Peacock, the cost of actually bringing point-of-care diagnostic to market was possibly at least 38 million, with adjusted for inflation, probably 42 million. But I do a whole article about that. So I just want to say that, collaboration with ZP, certainly is not in these ranges of 42 million, etc. In fact, we've brought people to market much lower cost than that. But they do have to be well funded in order for a ZP to really play a role. And I'll put a link here. Otherwise, we can help you through the provision of technology through the web store. And I did do a demonstration on the platform earlier on. Just some key features, that I know we're scientists and engineers, so people are interested in accuracy and reliability. So accuracy, I would suggest, and reliability does come from that discussion between carbon versus gold. But really, there's also speed. So one of the questions is, how fast will your assay be? People don't want, and you saw the way I did my assays just now, actually, especially the third demonstration. It was very fast. So ZP, we're very good at actually getting this speed. Ease of use. Did you see how quickly I set that potentiostat up? I got those settings going. I actually, so speed of use and ease of use, rather, is something that we very much focus on. Portability, boom, very portable. I'm just kind of saying these are the key features of a point-of-care diagnostic technology, and this is something that ZP has really worked upon. Robustness and durability. So, for example, we ship this all around the world. This is not a fragile device. We actually have a really pleasant case for it, which is all insulated, etc. This does ship with the unit as well. So we do have a robust technology that is used by real people in the real world and not just by people in labs. People want low cost and affordable. I do know what the price of point of care diagnostics is. So there's the Epoch, there's the iStat. I do know what their prices are. And I can absolutely tell you that this set of electronics, even at low volume, just the singly, is much cheaper than most point of care diagnostics that you would find in a hospital setting. You definitely see that we achieve minimal sample requirement. Connectivity, this is Bluetooth connected. I sent all the data to the cloud. Regulatory compliance. So ZP absolutely is ISO 13485, but it's not low cost to get regulatory compliance, but we are set up to do that for clients. You can also see that this is maintenance free, operational. In fact, it's you wouldn't maintain this, you would actually replace it, but we've definitely, we're shipping these, we give them 1 year warranty. In a hospital setting, in fact, I think they would find this kind of the kind of price point on this, I don't want to say funny, but they would find it very low cost, and that means that actually you can replace it if there was ever essentially a breakdown. And then the fact that it is cloud enabled, I think, allows it to be integrated with care pathways. It does have, the cloud system we have does have an API and application program interface, so we can actually plug into electronic medical records, etc. Now, question number 2, a completely different change of scope here. Somebody's recently purchased some oxygen sensors from us. They're asking for some questions. I just want to say that if you're looking for electronics for the oxygen sensor, we always link it. The electronics are linked to on the web page. I've got the link here. They were asking more about a sort of a pinout or something like that. So I just want to say the data sheet is here. This data sheet has always been in the public domain. And if you're looking to make electrical connection with this, we generally run it in a kind of classical electrochemical cell mode, working electrodes, the reference electrode and the counter electrode. So working, reference, counter, but that data sheet does has always existed. So question number 1, point of care diagnostics. To collaborate with ZP really does take a budget. If you don't have a budget but you can afford technology, you can buy the potentiostat, you can buy the screen printed electrodes. But if you want a formal, let's say, engagement with ZP, you really do have to have the budget to really get ZP on board. But you can also see that we've actually spent a good 10 years really investing into the R&D community, because in fact this entire platform has been built to allow people to achieve a scenario where in fact they go in, they can do an investment pitch, they can show some hardware and actually raise the money that's otherwise necessary. And just be very careful if you're a founder, you're going to focus on what you're strongest at, which often will be science and engineering. But the real question is, how do I raise the kind of money that it needs to do this? And then for our oxygen person, I'll put a link back to the website. There's a data sheet up there. I've shown you where the data sheet is, and I've also just told you where the pinout for that particular sensor as well. Now, if you have any questions from ZP, please don't hesitate to reach out to us. As you can see, we put a lot of effort into illustrating the answers that we like to give on this webinar. Okay, thanks very much.